Hello, everyone, and welcome. Please watch this video to make the most of your webinar experience as people are. Hello, and welcome to today's live event. Add artificial intelligence to your SDLC, design, development, and testing, presented by Applitools and Curiosity Software. I'm Pam Morgan with Applitools, and I will be the session host today. Applitools is happy to be presenting today's event with Curiosity Software. It's my pleasure to welcome our speakers and introduce them to you. First up, James Walker, the co-founder and chief technology officer for Curiosity. James started his career with a PhD in visual analytics, combining human problem solving with computer processing power. He has applied these groundbreaking approaches with a focus on model-based design, test generation, and test data automation. Before co-founding Curiosity, James was a senior engineer at Grid Tools and CA Technologies. Curiosity are pioneers in requirements engineering, automated test generation, and test data automation. This year, they've introduced a range of new capabilities that combine the power of generative AI with model-based testing. Many of those you'll see today. Next up, Anand Bagmar, a solution quality evangelist and a solution architect here at Applitools. Anand has more than 20 years of experience in the software testing field. He's passionate about shipping quality products and specializes in quality strategy and execution. A contributor to the Selenium project, he has built a number of open source tools related to software testing and regularly speaks and writes on testing related topics. Applitools offers the industry's next generation test automation platform powered by visual AI. Applitools Eyes was the first market solution to replicate the human eye and automatically spot functional and visual bugs. Now, with the ultra-fast grid, Centra, and the execution cloud, nearly everyone in the organization is seamlessly integrated into the testing process. And finally, Thomas Price from Curiosity Software is also here today in the chat and will be helping with your questions. Be sure to give him a thumbs up. As a reminder, this event is being recorded and will be shared with all registrants tomorrow. James and Anand will primarily be answering your questions towards the end of their presentation, but please add them to the Q&A tab as they arise. Should you encounter any other technical issues, feel free to direct message me, Pam Morgan, for assistance. And with that, Anand, I will turn it over to you.
Thank you, Pam. Hello, everyone. Just getting my screen shared. Okay. So welcome to the webinar on adding artificial intelligence to your SDLC. Why do we want to add AI to our software development process? Well, the answer is clear. We already had agile, continuous integration, continuous deployment, because we want to get our software in front of our users much more faster, and not just faster, but with good quality. To do that, to have the quality product, we need to ensure we stop testing, finding for defects, and instead focus on preventing defects. To do that, of course, one key aspect is we want to ensure the feedback is going to come fast from various different stages of our SDLC, so that everyone on the team, and this includes everyone, all the roles, right from business, requirements, development, testing, DevOps, SRE, and whatever other roles we have, everyone wants to and should get quick feedback to how the quality of your product is. Now, to get this fast feedback, we need to be agile and nimble on our feet when it comes to the testing life cycle as well. The testing life cycle, if you think about it in simplistic view, what the different stages are, there would be requirements. Based on that, you come up with your test design, your test cases. You will implement those tests in the best possible way and automate them. Once automated, you want to run those tests and run it quickly. But what's the value in running the test if you cannot analyze the results in an easy way and take decisions on what the quality of your product is, where the problems are, and how can you get better at that? So this is the problem statement that I'm going to turn over to James and ask him, James, do you think AI can help in this testing life cycle? How can we make our life easier and get that quick feedback?
Love it. Not a small question. Yeah, I think in a nutshell, can AI help? Absolutely, it can help. And hopefully I'm going to give some examples of how AI can be put into the mix and some of the solutions that are out there already today, which organizations are leveraging, and different various ideas that are kind of appearing in the market as well. So really what I'm hoping to show throughout this session, and Anand has some pieces he's going to jump in with during as well, is kind of how can we use AI, to help us with quality while also maintaining speed. I think if you look across almost every organization at the moment, everyone is trying to do more. You're trying to move faster, but often we're kind of limited with the amount of resources we have available. And that's not a very good equation to have, trying to do more with less. But that's kind of what we're facing in the industry at the moment. Now, we could just jump straight in here and talk about AI, start showing some solutions and some technology. But I think the reality is, even before an organization starts to think about AI, there's probably quite a bit of work that needs to be done, right? I think if you look generally at the testing industry, especially over the past kind of 8 to 10 years, we've kind of oversubscribed to various silver bullets over time. I think automation has pretty much been the latest silver bullet that has kind of been sold throughout the industry. If you implement automation within your organization, you're going to go through and solve all the challenges and all the problems that are faced in front of you. But I think the reality is that, if we look at testing or we look at quality, which I like to use more often, is actually if we want to improve quality in an organization, there's some serious hard yards that we have to go through first, right? And I think, a good mantra is we kind of need to walk before we can run. And adding AI into mix, adds another level of complexity where actually we need to get our house in order before we can go through leveraging these advanced algorithms, leveraging these advanced techniques. So I would see AI almost as an evolution of quality, an evolution of, improving your testing. It's certainly not the be all and end all of everything out there. Okay. So a couple of things which I think organizations probably need to work on before they start thinking about implementing AI, or, if you're thinking about and you're kind of along that AI journey already, what kind of challenges are you guys going to have to work on as you're going through? So I think the first one is around garbage in, garbage out, which is a term we throw around a lot, especially in the machine learning industry. And basically what that means is that if you have bad data and you try and do intelligent things with it, or you have a system which has bad data in, you start to query it, the end result is that you're more than likely 9 times out of 10 going to get a bad result out the back end. Okay. And I think in the software development industry in general, the data we have really isn't good enough. If you look at requirements, often they're trapped inside SMEs' heads. So we find that, knowledge is kind of dispersed amongst multiple people or multiple teams. The systems we have aren't really joined up as well. So we'll talk to a lot of organizations, and often we'll say, what systems are you using for you to track your tests and your requirements? And typically there'll be several systems in place. There may be a bit of Microsoft Word, there may be a bit of Microsoft Excel. Typically there may be a bit of Jira, and then there may be a bit of some kind of test case management tool along there as well. And really, if we want to start leveraging kind of more advanced algorithms, especially when you look at large language models, you need to have really rich sets of data, which is structured and up to date, and everything kind of feeding into each other. Okay. The second one is around security. I think this is especially true with large language models, because most organizations don't have their own large language model at the moment. So a lot of organizations are leveraging either OpenAI, or they're going through kind of the Azure or Google Cloud portal. And obviously with that, there's various kind of security concerns in terms of offloading your data into those various systems. I think we're going to see a bit of a shift, especially in the coming year, of the technology becoming available that organizations can run their own language models, they can train them on their own data. But I think one of the primary concerns we're seeing in organizations at the moment is around security. The third one we have here is probably more beyond kind of technology. And this is really about people and processes. I think, often, and I'm especially guilty of this coming from a company that sells testing software, we tend to focus a lot on the tooling that's available. And, we sell a lot, of the features that are available in the tool. And these are the amazing things you can do with it. But actually, people and processes are really, the focal point of having and improving quality within an organization, right? If you don't have good people to start with, your quality is obviously not going to improve as a result of that. In fact, it's probably going to have the negative effect. But also, if you don't have good processes where you're doing review cycles and you're really embracing trying to drive quality throughout an organization, any changes in terms of any tooling or techniques that you bring in aren't really going to have that much of a big impact, right? So I think, Agile is obviously a great methodology for getting teams together and bringing them in. But I think, it's more around building a culture which drives around quality. And then as a result of that, it's going to be building a culture that can leverage these new techniques and new algorithms as they come through. So what we thought we would do during this presentation is kind of take you through the software development lifecycle. And as we're going through that software development lifecycle, what we really want to do is touch on how AI can be leveraged in every stage as we go from design into development, all the way over to test, and finally into the production stages. Okay, so the first stage of any software project typically starts with some kind of software requirements. Okay, it could be, pretty heavy. Maybe you've got various compliance issues that you have to work around, especially in the finance industry, where you're going to have probably really big requirement documents that come along with a particular, enhancements or procedure that needs to be built out. Or it may be a little bit more lightweight, where you have various user stories and, you're in a bit more of an agile environment per se. So, but typically the software development lifecycle starts with some kind of requirement that needs to be built into the software. Okay. And as part of that, we need to get an understanding of, what needs to be built in our application. Okay. So within Curiosity, as Pam mentioned at the beginning, we do a lot of work with modeling. Okay. And modeling, it sounds like a very complex term, But really, it's just all about building diagrams and building diagrams of the particular feature and the particular component that is going to be built. Okay. So what we want to do now is show you a bit around modeling, some of the benefits from it, and how we can get around, firstly, building better requirements. So moving away from ambiguous requirements, being able to collaborate on quality by getting everyone on the same page, and being able to leverage AI to help us build and enrich the requirements that we're creating. So this is where I want to jump into the first demonstration that we're going to have throughout this webinar. Okay, so I'm going to come over to one of the many browsers I have open at the moment. And what I'm going to do is walk you through a couple of examples of modeling and then show you a bit of AI and how it can be used to help accelerate models and that model creation process. Now, what you're going to see here is the Test Modeler platform, which is a tool provided by Curiosity Software. And basically, within this platform, what we have is the ability for users to log in, and you can create projects. And the idea is you can collaborate in a workspace to build out your automation and your various assets to drive quality throughout your software development lifecycle. Now, throughout the examples that we're going to be showing today, we're going to be looking at an e-commerce based system. Okay, and within this e-commerce based system, we have lots and lots of things. We have different products that we can go through, and within a product, we can specify different sizes, quantities. We can add products to the cart, and then eventually we can go through the whole checkout process of our e-commerce system. Okay. So as you can appreciate, we've got a few steps here, a few components we have to go through to automate this application we have in front of us. Okay. Now, when I'm talking about a model, this is basically a model we have for that e-commerce system we're looking at here. Okay. And what you'll see is that we've got different steps we have to go through in this e-commerce system. We can go through a menu, we can go through a login, a catalog, a shopping basket, and a checkout. And you'll see there's lots and lots of processes here that take place. Okay. Now, the benefit of modeling is actually what you're looking at here is a higher level representation. It's very easy for me to see kind of the end-to-end process that I can go through my e-commerce system in. Okay. But actually, if you look behind the scenes here and we start to explode these, what you'll see is that behind each of these components, there's a whole world of embedded logic, which represents going through the catalog, the shopping basket, the checkout, and also the login system that we have down here as well. Okay. Now, this is kind of the power and benefit of modeling. It's incredibly visual, so users can come in and they can immediately see this is how a certain part of the system should work. But also what you have is this element of componentization. So a lot of organizations now are trying to move into the realm of kind of end-to-end testing. And if you think about end-to-end testing, you have lots and lots of steps you have to go through to complete a much bigger end-to-end chain. So with modeling, you literally model something once, that becomes a reusable component. And then as I go through and I decide to build out my much bigger end-to-end scenarios, I can basically come in, build out, bring in my different components, connect them in and build out and drag and drop my kind of end-to-end chains that I want to build into my system. Okay. Now, a model doesn't have to just be flat like this. What it can also be is a bit more graphical. So here what we're looking at is a wireframe we've started at. Okay, it's not the most complex wireframe in the world, but hopefully you can see this, you get a visual understanding. This is representing some kind of flight booking system. We have an origin, a destination, a travel class. We can search various flights. We click a search button at the end and we get back a list of flights that we can eventually go through and book. Okay. Now, what we also have with this flight booking system is the ability to come in and we can specify out the different logic that exists behind this flight booking system and the different requirements we have for it. So we can specify an origin, a destination. We can specify numbers of passengers. We can select the class of travel. We can select the trip type. And at the end, either we end up getting back a list of flights and we can successfully book that, or we end up in some kind of error situation where we've entered some invalid data and we're expecting various error messages to be displayed. So we're moving away from this kind of textual-based representation of requirements into this visual world of modeling, where we're visually defining how a requirement works and how it should take shape. Now, what we've been working on over the years is obviously we've been doing a lot of work with models, and we've seen organizations drastically improve their quality by moving into the world of modeling and having everyone collaborate together. But like most people on this call, I think when we saw, ChatGPT, especially when we went from 3.5 to 4, we really couldn't believe kind of the effectiveness and how good the large language models were that existed, right? So what we've been looking at is how can we use large language models to help organizations move into the world of modeling and help them create better requirements and move quality and testing kind of further left in their software development lifecycle. So one of the examples I want to show you here is basically being able to take text and move into the world of modeling. So here what we have is basically a little requirement for a drinks promotion that exists. So there's a drinks organization, it could be Starbucks, it could be a similar one out there. But basically, they're offering a drinks promotion at the moment. And basically, as part of this drinks promotion, a customer must run a minimum of 10 miles per week in order to qualify for a free drink. Okay. Customers must track their miles and present the results to a cashier in order to receive the promotion. And the promotion is valid for a limited time period and is only applicable for select drinks as determined by the establishment. And there's a final rule here, which is customers must be 18 years or older to participate in the promotion. Okay. So we've got a bit of a text-heavy requirement with some business logic embedded inside it. Now, what I'm going to do here is click Generate, and that's going to leverage a large language model here to go off and create a model which represents the drinks promotion that we have taking place. Okay. So I'm just going to zoom in a little bit here to make it a bit more clearer. What you'll see is at the beginning we start, and then we have a question. Is the customer tracking their miles? If they are tracking their miles, we ask another question. Are they running 10 miles per week? We ask another question. Are they going to present their results to the cashier? Is the promotion valid? And what you'll basically find over time as we go through this model is you basically can work your way through it in the different scenarios, and either a customer is eligible for the promotion because they've met the criteria, or they're not eligible for the promotion because they've dropped off at one of these decision points where they've not tracked their miles or they've not met the conditions of that particular promotion that takes place. Now, hopefully you can respect that visualizing this model and being able to work your way through it visually is much, much easier for someone to go through than it is to go through this textual-based requirement and have to unpick it and understand exactly what logic embeds inside this text here. Okay. What we typically find actually is when we're talking to organizations and working with them, if you look at a lot of the good testers out there already, they're kind of building this mental model of how the user story in front of them operates anyway. And, you kind of find either users or testers will go in, they will build this model mentally, or they may have a big pad in front of them where they're kind of drawing out this visualization of all the different routes they could work their way through the requirement and how many ways they can test it and kind of break the logic that's embedded inside there. So there's a lot of testers out there that are modeling already, just potentially you guys don't know that you're doing it. So here we're just trying to formalize that process to move into the world of modeling. Now, what it also turns out is that models are a fantastic resource to start to enter the world of querying and being able to use them for kind of advanced questions and being able to leverage them in large language models. So here what we'll see is we have a model, and this model is basically for a login system. So we can go through a successful journey, we end up authenticated, or we can end up in some kind of error state because someone's entered an invalid password or an invalid email, and we would expect some kind of error message to be displayed as part of that, that they've entered something invalid. Now, on the right-hand side, what you'll see is we basically have a co-pilot here. And what this co-pilot allows me to do is to come in and specify different prompts to use the model with to either answer questions or to go away and do something with it. So the first thing I'm going to do here is I'm going to say, can you go away and review the model for me using our large language model and give me some hints if there's anything I'm missing. Okay, so I've said review the model. And what you'll see here is our large language model, if I just zoom in a little bit, has taken this model and come back with some text here about it. So it says here, overall structure of the flowchart appears complete and correctly structured. It appears applicable for model-based testing, which is great. There were no errors detected on the flowchart. However, some scenarios may be missing. For example, it does not account for scenarios when a user enters an incomplete email address. Additionally, there could be a scenario missing when the user enters a wrong password or previously registered password. Also, there's no mention of a verification control mechanism after entering a valid email, such as sending a verification code. So it's come back with some recommendations here of things that may potentially be missing in our model. Okay. Now, it's not perfect, and obviously it's used its real world knowledge to come back and say, you know, what may be missing from this model and what may not be there. Okay. So a lot of that is going to depend on what the large language model was trained on. But here, what we're basically saying is, give me some hints. You know, is my model accurate? Is it up to date? And is there anything else in there I should be considering? And what we could also do is we could come in here and we could ask questions. So I could say, when is a user authenticated into my system? What that is basically going to do is go away, take the model we have and the logic. It's going to take my question I have here. It's going to perform a query, and it'll come back with the answer here that a user is authenticated when they enter a valid email and a valid password and they click the sign in button. So all of a sudden, we're kind of entering this world of not just having kind of static, models. We've also now got the ability to go in and start to use a co-pilot to help augment our models and help us answer advanced questions about various knowledge which exists, but also being able to go through and ask it to go away and potentially help and aid us in building our models and testing the systems that we have. So that was kind of step one, thinking about requirements and thinking about how we can use AI to help us build better requirements and remove ambiguity from how and what we're testing, and building models together to improve collaboration and hopefully improve quality as a result. The next one I want to move on to is more into the design and development stages. So what we often find in organizations, as I mentioned before, is often there will be kind of this disbursement of knowledge across an organization, particularly when it comes to legacy applications. It may be that there's some requirements that exist in Jira. It may be that, it's kind of scattered across the landscape in terms of where various knowledge is. So one of the things that we've been thinking about is how can we build out a knowledge engine to help organizations make sense of all the data they have in front of them and be able to ask questions about their requirements and hopefully start to get some sense of understanding of all of the requirements and all of the knowledge that's been gathered up over time for a particular project. So one of the things I want to move into next, close this one, is going through and looking at some requirements we have inside a Jira board here. Okay. Now, if you look inside this Jira board, it's basically got requirements in here for a banking application. So we have things like being able to transfer funds to another bank account, being able to receive funds from a bank account, being able to view a transaction history, being able to create standard orders. And then I think as we go down, we've got things like credit card applications, applying for student checking accounts. If I open up some of these stories, what you'll see is that they have their own kind of world of requirements in here and different acceptance criteria along the way. Okay. Now, what we have done is we have scanned these sources of information. So we've just gone in and connected to Jira here. We've scanned those requirements that are available. And then what we've basically done is on top of that, we've used it to augment and train a large language model on top of Jira. And what that means is we can come in and we can start to ask some questions in here about the requirements that we have inside our Jira board. So at a first level, I could come in and I could start to ask a very basic question. Now, obviously, we don't need AI in the mix to answer this. We're basically asking, what is Jira ticket CB13? So this is one of the Jira tickets that we just had open here. And basically, our large language model has come back. It said, we've recognized the CB13 Jira ticket is probably a relevant source of information. And it's come back with an answer here. It's a software ticket that corresponds to a user story for applying for a credit card. And it's got the details here about the credit card application process that we're going to go through within that story. It's not particularly amazing, but we've asked a basic question here and it's come back with a response. Now, what we can do is we can go a bit deeper here, okay? So we can ask a question like, when can a customer apply for a home loan? Now, this is a bit more of an advanced question. We're not specifically referencing a user story, but we do know that we have Jira tickets for a home loan and the different business logic that exists for when a customer should be able to make that application. Now, what we'll see down here is we've actually used a couple of sources of knowledge. We've used the Jira ticket CB14, which goes through and talks about applying for a home loan. Okay, so we've got a Jira ticket here. But also what it's done is it's detected that we have a model within our workspace which is relevant for applying for a home loan application. So we've got various logic within here that goes, much deeper than the textual requirements we had. Now, using those sources of information, the AI has come back and it said, based on the provided user stories, a customer can apply for a home loan when the following conditions are met. Customer is a prospective customer. We have a certain credit score. They're qualifying for the home loan promotion, et cetera, et cetera. Okay, so we've come back with the answers here of what is the criteria to answer our question. Now, we can go even more deeper than that, and we can ask an even more advanced question. So the two questions we've asked so far are specifically pinpointing on one requirement in particular or a couple of sources of information. But now what we can do is we can ask a more advanced question, which is spanning across almost the entire kind of landscape of tickets that we have. And this one is saying, what can I apply for if I have good credit? Okay. And what's come back in here is we have several sources of information that may be useful. And it's come back and said, if you have good credit based on the two user stories that it thinks are relevant, you can apply for a savings account or you can apply for a premium account. So we can come in and we can start to ask more advanced questions to cover knowledge in our software development lifecycle. So if you think about an organization, there could exist lots and lots of technical debt. And what we're trying to do here is help organizations get a grip over all of the sources of knowledge they have to be able to reduce technical debt and enhance understanding across a particular project that may be happening in the software landscape. Okay. Now, the final one I want to talk through, and I'm going to hand over to Anand in a second to give a bit more detail on this as well, is basically going through test design and script creation. Okay. Now, when we look and talk to a lot of organizations, what we've actually discovered over time is one of the challenges an organization will have is around understanding their coverage and their test coverage in particular for parts of the system. And basically, it comes down to the question, how well are you testing and what level of confidence do you have in what you're releasing? Okay, is it of a good enough quality? So what I'm going to show you basically is how we can use modeling to move into the world of introducing test coverage and also introducing visual assertions along the way to help with that. Okay, so one of the examples I want to start through is this login form we have, which is part of the e-commerce system that we showed you earlier. Okay. Now, what we can do with that e-commerce system is we can basically come in and we can start to scan the different components we have within our application that we want to test. Okay. Now, as part of that scan process, what we've basically done is we have gone away and we have built out a component library of all of the different identifiers which exist for each of the different elements we may want to interact with as part of our testing. So we've got the enter password, we've got all the different automation identifiers, the same for username, the same for the sign-in button. What we've also done as part of that scan process is we have used some AI to help us go away and build out a model automatically, just as part of that scan process, of how our login system should be tested. Okay, so what you'll see here is we go to the relevant URL, we can enter a username, and we can have valid ones with test data behind, or we can have invalid usernames as well. Then we're going to come down to entering our password. If our username and password is valid and we click sign in, we should be authenticated. If we enter some kind of bad data, that's where we'll enter an error condition, and we should see some kind of error message be displayed as part of that. So again, just by scanning the application, we've applied some AI here to help us build this model. And then what we can do next is once we have this model, we can hit the generate button here. And what that is going to do is it's going to go away and basically use some algorithms here to determine the minimum number of tests to maximize coverage over the application or the process that we're testing here. Now, in this respect, we're just dealing with a login system, so we don't have a huge amount of paths. But when we start to come up to a much more complex flow, so if we think about the whole shopping cart holistically, where we've got several processes and steps that we have to go through, if we hit the generate button here, what it's going to do is it's going to compute those minimum number of test cases which span across my entire process here and everything in between that comes across with it. Now, one of the things we have embedded on top of this model as well is our automation. So here we have various automation actions which exist to go away and automate different components in our app. What you'll also see here is we have Applitools actions based on top to go and perform our visual assertions as well. And what that means is once we have these paths produced, we can come out, we can hit the export button, and we can say, go and generate my automation code for me, and then go and trigger the execution. Now, at this point, I want to hand over to Anand, who's going to talk a little bit more about visual assertions and also the Applitools grid, which can speed up execution. So, Anand, are you okay to take that over?
Awesome. Has the product already evolved more, James, since the last time I saw it? No, it seems fantastic. It seems to be much more than
AI, I think.
Yeah, probably. So thank you so much, James. I think it was very interesting how we can build or leverage AI into our design, our requirements, understanding and visualizing the requirements, and also generating tests out of that. As you mentioned, we already have Applitools integrated as part of Curiosity product to leverage and get more value from AI. But if I have to take a step back to what we started off with, right? We've got all these different aspects that you covered, how we can leverage AI for it. From an automation perspective, I want to quickly talk about how Applitools can add additional value based on what you have just said in this all these different areas. For this, I'm directly going to jump into a demo and show by action what this really means. We have the tests that are executed, generated and executed using the platform, as James mentioned. When you run the test with Applitools integrated and visual validations happening, you will see the results come in the Applitools dashboard. In this dashboard, you will see a summary of the results. That's one of the feedback that you get. What are the different tests that you have executed, and what does the overall summary of that execution look like? We can dig in deeper into that test and see, okay, here was the shopping cart test, add to cart test that James ran, and this test has passed. This test has passed based on various different visual algorithms that we have integrated or used as for the validation. Left side is the baseline, right side is the screen that was captured. And using the strict AI algorithm, Applitools is saying there is no difference found in these from a functional perspective as well as visual perspective. In fact, to make it more interesting and valuable, what we have done is, because there could be dynamic portions of our application, for example, the count of items that are available, that is going to be dynamic based on the inventory. So I'm able to use a different algorithm layout, which is an AI algorithm. And it says, I don't care about the content, but I care about the structure. Is everything as expected in this? And this is very important because if the product inventory changes, I might end up with false failures. If I'm looking at a different type of product, the menu bar, the filter criteria is going to change again based on type of product. So I might want to use different ways, different techniques to do the validation for me. Likewise, you can use n number of validations on the screen if you want specific validations to happen. Or you could also say, I want to validate the whole screen using one algorithm only. You would also notice that Applitools is able to validate full and long pages as well, and it takes care of the stitching, how that needs to happen. Let's look at some other interesting examples where things are not passing. It's seeing a passing test is of no value, right? Now, the value is to see when the test fails, what are the reasons it has failed, and is it capturing the right type of details? So in this particular case, I just want to showcase the power of the algorithms. So in this case, though it's an Android app, it could have been a web app or PDF document, anything. Applitools is able to use the strict algorithm, which says anything different to the human eye, show that as a difference to me. And here we are able to see all the differences highlighted. Now, you could come over here and inspect and say, oh, these differences are because of change of data, and I don't have control over the data that comes into the application. It is going to be dynamic. So let me use a different algorithm. This validation does not help me. So in that case, I could use a layout algorithm over here for a specific region where there is dynamic data. And now you see that the pink region that existed earlier is going to change, and we'll see validations based on the layout algorithm, which is ignoring the dynamic content, and it is saying everything seems to be fine over here. Even though there is content difference, color differences, the numbers are different, it is saying this is all fine, except one aspect, which is a difference. There is some data that is missing in this one label. Now, on inspection, you could say, oh, this is actually because of a defect in your front-end application code, or it could be a defect in your back-end code, the APIs that are fetching the data. There's some problem somewhere. And at this point, you could create a defect directly into your defect tracking tool, saying there is some data is missing. And at this point in time, you have found a functional issue by doing a visual validation. That is a point which is very important. When you run these tests using Applitools, you are not just validating the UI, you're not just validating the user experience, you're validating functionality. And that makes the test implementation much more simpler, because one call to Applitools takes care of all the validations. You do not need to write code for each and every specific detail if that is correct or not in your application. Applitools will do that for you. Likewise, you could have many different combination of algorithms on the screen. You could also look at if your application is localized, how you can test different languages if that conforms to your design very easily as well. So here's an example of a Facebook login page, different languages. Using the layout algorithms, we see there is one difference that is highlighted, and that difference is because of the content is overflowing from the text box over here from a structure perspective versus in the screenshot that was captured, it is not the case. So Applitools AI is able to capture the layout differences and highlight to you what and where the changes really are. This is a great use case from a localization testing perspective, because the team might not have the skill sets of the different languages, but using the layout algorithm, you'll be able to validate if structurally everything continues to be fine before you get to specific language validations as well. For the specific language validations, if I move to the strict algorithm, assuming this was supposed to be the same language, all the differences that as humans we can see are highlighted using this algorithm, and whatever is similar, like the image, the logo is similar, that is not highlighted. It is easy to get confused that the strict algorithm might be doing pixel matching. Here's an example of a exact algorithm which is doing pixel comparison, and you can see almost the full screen is highlighted in pink as differences found, because at a pixel level there are differences. There are almost the whole screen is different. So pixel matching is very different from the strict AI algorithm, and that actually gives a lot of power to the teams. Now, this is from a functional validation perspective when we are running the tests, but that is not sufficient. We typically have to run our test not just on one browser. We need to validate the functionality on all the different browsers and devices that our application supports and that the users are going to access our application from. So a typical cross-browser testing strategy is, if I have these 9 tests over here, if I want to run these 9 tests on all different browsers, I'm going to repeat the execution of these on each and every browser and see if everything is working fine. But with AI, you can evolve your cross-browser testing strategy and simplify it significantly. What we can do is, all you have to integrate in your Applitools configuration, provide the set of browsers and devices that you want to do the validations. And when you're running the test and you tell Applitools, validate this particular screen for me, Applitools will automatically render the same screen on all the different browsers and devices and do the validation automatically for you. This is very different as compared to our traditional cross-browser testing strategy, where we are going to execute the same test on each and every browser. That requires a lot of infrastructure, a heavier test environment. You might need a lot of test data. The network traffic is going to increase as well. And there are a lot of failures when it comes to executions on different browsers related with timing issues or so on. And you can avoid all of that by leveraging the ultra-fast grid from Applitools to scale this execution in a much more seamless way. And what that means is, if I had this one shopping cart test that I ran on Chrome on my machine, using Applitools ultra-fast grid configuration, I could simply provide additional browser and viewport size combinations or device combinations over here, and automatically I can get the feedback of these tests running as part of the same test execution cycle. And this part is very important, because if functionality works on one browser, it will continue to work on all the browsers unless your application has browser specific components implemented. In that case, definitely you should run those specific tests in all the browsers directly. But if you are using browser agnostic solutions for your product development, then you will be able to just run the test once on a browser. If it works fine, you can be assured the test will run fine on all the other browsers as well. What is different is the way rendering happens in each browser, because the browsers still control the or implement their own rendering engines. So you want to make sure the validation happens from each browser independently. And this is what the ultra-fast grid gives you out of the box. And when you run this test against different browsers, different viewport sizes, you can notice in the thumbnails the difference of the screen sizes, because your applications are responsive in nature. It is going to render correctly in the ultra-fast grid, and then validations happen automatically for you. So this execution runs very fast. If you have 100 tests, which takes 1 hour to execute on one browser, 4 browsers would mean 400 tests, which equals 4 hours minimum of execution. With the ultra-fast grid, you could get feedback from 400 or more number of platforms in just about 1 hour, 5 minutes, 1 hour, 10 minutes. That is how fast the ultra-fast grid is going to be for you. But this is not the only thing that you can get value of AI in your test execution. There is more. James referred to self-healing capabilities as well. And that is very important because your users don't really care about locators in your application. The users care about, can I click on a button? Can I proceed? Can I enter data? Can I proceed? Can I see the data in the right fashion? Right? So why should our test automation be limited or worried about the locators? And that is where the execution cloud from Applitools comes into picture, where you will be able to run the test in the Applitools execution cloud, which automatically gives you the self-healing capabilities, and you can run the test in parallel on the ultra-fast grid from the execution cloud, so it makes it even faster. What that means is, when I run the test in the execution cloud, you will see the same behavior in the test execution in the dashboard over here, with the additional detail this ran on the execution cloud. But the value is really seen when, if a locator has changed, and your test will fail. If you're running in the execution cloud, Applitools will try to find an alternate locator that you can leverage, that it can find to interact with that element and proceed instead of failing the test. And only if it finds a reasonably accurate locator, it will use that for the execution. Now, being a tester by heart, I find self-healing a very risky proposition as a tester. What if the location of that element has changed that I'm interacting with? It has changed somewhere else in the screen. My user experience is going to get become a problem in that case. But when you tie self-healing with visual validation, you can be rest assured the functionality is validated correctly if you can heal the locator and proceed. And in addition, you get visual validation to understand, yes, everything is indeed as expected or not. So as you can see in this case, this test has a magic wand, which means there was self-healing used for this test. This was the original locator. This was a new locator that was used to continue with the interaction, and the test continued. And you're still able to get visual validations done as part of this test, where you can zoom in and see what the differences are. And in this case, we see that the text in the search box has changed. You can use root cause analysis to figure out what has changed in the DOM and CSS, why this change is seen on the screen, and you get much more additional information from your execution. You can also download the video of the test execution, get the WebDriver logs, console logs, and so on, so you can get rich information about the execution as well. So to summarize, you need to have a holistic quality strategy for your product. If you want to leverage AI, the existing way of working and just using new tools will not give you as much benefit unless you take a step back and say, what is the power and capabilities of these tools that you're using, and how can I leverage that to the best possible way? So you need to evolve your quality strategy. You need to evolve your automation strategy. You need to think about, how can I get this feedback earlier to the developers, to the product team, how the product quality is. And for that, the ultra-fast grid, to scale it and make sure it is compatible with all the different browsers and devices, is a very important aspect as well. Including visual validation as part of your automation strategy these days, to me, is a no-brainer, because if your application has a user-facing, if your application is a user-facing application, and if there is a risk of certain functionality or user experience not working well for the customers, for your users, then you definitely need to include visual testing in your automation strategy, because you cannot risk having those types of issues go out to the customer. The Applitools Visual AI can add AI power to your functional automation for your functional and visual validation. You'll be able to do this by writing less code, get additional test coverage as part of it, and with the self-healing capabilities, your test is also going to be more stable. With the Applitools AI approach, you need less locators as well to implement your tests, do the validation. Hence, you're going to get less defects in production. And when you combine Visual AI with the ultra-fast cloud, you get AI-powered cross-browser testing. You do not need to do the traditional cross-browser testing anymore. It does not give enough value. There is a lot of effort to make it work and get value. Instead, you can get much more value in a much more shorter time using AI-powered cross-browser testing. It also needs less test data, less load on the environments. It is less flaky, and it is super fast. Lastly, the Applitools Execution Cloud will self-heal your tests. It will run the tests in parallel. It is also going to be able to test local applications. And that becomes a huge value add in stabilizing your tests. Focus on the functionality, not on the locators. That is what your users focus on as well. So I hope this gave you some interesting insights, how you can leverage what James mentioned from a curiosity perspective, from design, requirements, test cases, identification and creation, to execution using visual AI, how you can get the power of this. James, over to you to close.
Yeah, I think we've only got a few minutes left, so I'm just gonna kind of rattle through it a bit quickly, I guess. But I think, firstly, the visual grid and the execution grid that Anand has just shown there, for me personally, that's been one of the biggest problems for automation, right? It's like, there's never enough time in the day to run the tests, but also when you do end up running them all, you end up with so many tests failing because they're just brittle by nature, right? So having that self-healing, that's such a huge leap forward in the industry, right? But I think, in summary, just to kind of wrap up today, I think what we're seeing at the moment is there's obviously massive disruption, right? Large language models, generative AI, everything else with it. It's really disrupting all the technology that's out there. And we're seeing massive leap forwards in other industries. And I think we're starting to see the same in the testing industry at the moment. If you look at a lot of products out there and the direction they're taking, it's mostly going down this kind of co-pilot approach, which is almost taking the existing product today, adding on AI capabilities to help accelerate what users are trying to do today in the product that they're familiar with, right? But I think, the direction that I'm most excited about over the next kind of 12 to 18 months is when, products start to get released, which are built with kind of this whole AI mantra first built into them, right? And I know we're at Curiosity thinking about this, seeing, a lot of the work Applitools have been doing, a lot of the announcements recently, and knowing the team, I'm convinced they're going down this route as well. So I'm particularly excited from both sides to see kind of the new evolutions and the new products that are going to be delivered over the next kind of 12 to 18 months. So I think probably a good time to open up for questions, I guess. Thank you so much for everyone who's stayed with us along this webinar so far.
Awesome.
Thank you, gentlemen, for a great presentation. Let's see what questions our audience has. Okay. Our first question, can we do accessibility testing through Applitools? Anand, do you want to handle that?
Yes, I can take that. Yes, we can. Applitools has a contrast advisor feature from an accessibility testing perspective, which you can integrate as part of your automation, or you could directly see this in the dashboard as well. The beauty of this solution is the contrast advisor will work for web, mobile web, PDF documents, native applications, desktop applications, anything. So Suchendra, if you can connect with us, we'll be happy to give you a quick demo of how this works, and you can see how it can add more value to you.
All right. A reminder to the audience, please add your questions for James and Anand on the Q&A tab. That helps us prioritize them and bring them to the stage. One common question that comes up is, what skills are required to start modeling? James, do you want to take that one?
Yeah, sure. I think one of the things that we often see companies struggle with is a bit of a mind shift change from going from writing kind of these lists of steps into thinking about a model and thinking about the different scenarios for a system. But I think one of the things that I mentioned earlier is if you look at good testers, good developers, often they will either build this mental model anyway, or they'll have some kind of A4, A3 pad in front of them, and they're drawing out all the different scenarios. So sometimes, the people who struggle, maybe they weren't the best, tester or developer in the first place. So often it does end up, kind of being this separation, I guess. And, some people do struggle with that. But generally what we see is by introducing modeling, by helping people think about the methodology and think about the system, just usually that process alone ends up improving quality as a result. So, yeah, I mean, it comes down to what we said before, tools, people, processes. We're selling a tool, but I think having the right processes can help the people which can ultimately help quality as a result. So it kind of all comes together in one, I guess.
Okay. We have a few other questions. I'll start with this one. Daniel asked, when you added a defect based on the visual testing, can the system or AI check if the defect is already present in JIRA, for example?
No, Applitools cannot check if that defect already exists in the system. But if you're creating a defect from Applitools, it will automatically apply using the AI capabilities. It applies that information to all the relevant screens as well automatically. That means you do not need to create duplicate tickets for the same issue. So that is one way of preventing duplicate tickets being added in the system.
Another question that's gotten a little bit of traction is, which automation framework, systems, and languages does test generation support?
Yeah, great question. I appreciate that one. So, I mean, for us, we're kind of technology agnostic. There's obviously frameworks that we kind of prefer, like Selenium is obviously super popular, Cypress we like, C#, JavaScript, etc. But really, we've tried to be technology agnostic, just because what we see with organizations is often they'll take the standpoint, what is the best technology for me to automate the type of application I'm testing? So from that perspective, there's lots and lots of technologies that make sense. So on the model, you just overlay different code snippets, different languages. And I see Applitools have the same as well. So that kind of embraces from both sides, I guess. Yeah.
All right, I see two more. Let's start with this one. How does Applitools handle the machine learning? Is Applitools delivered with a neural network already trained? And how to make sure this learning matches my interests? Is there a way to train it? Well, that's a tricky one. Anand?
It's actually an easy answer. No, it is a tricky question, but it is an easy answer. You can start using Applitools today right now. Sign up for a free trial account, integrate it with your test automation framework. Run the first test, it will create a baseline. Run the second test, it will compare with that baseline based on the AI algorithms of your choice. What that means is the algorithms are pre-trained. You do not need to train these algorithms in your context, in your application. What you do need to do is choose the algorithms or the combination of algorithms correctly in context of your application. Strict, layout, ignore colors in combination to get the best possible validation. As long as you have done that, Applitools will start working for you right away.
Excellent. And a little plug right there. There is a link in the resources tab to claim that free Applitools account. There's also a link for a free test modeler account on the resources tab. So be sure to check those out. All right, we have just a few more questions. Let's see. Reagan asked, are there plans to include Playwright in future supported automation tools?
Yeah, so I guess from the curiosity side, we already support Playwright. We have a couple of customers using it. Anand, I'm not actually sure from the Applitools side. You might have to pick that one up.
We do support Playwright. If you go to the applitools.com/tutorials page, you will find a Playwright tutorial as well over there.
Excellent. Okay, we've got time for one more question. Let's see. Kunal says, are we also adding new features in tools for upcoming applications which are developed using LLMs?
Yeah, I guess from our side, it's not something we've got into at the moment. I think as they become more prevalent, it'll probably be something that we start thinking about delivering some kind of material on, and probably do some white papers around that. But for now, it's such a new technique. I mean, really, we're only seeing kind of the big players like OpenAI, Azure, Google Cloud, and some of the kind of open source community moving in that direction. But I think as it becomes more prevalent, we'll probably start thinking about, and we'll be part of that community of how you test large language models and everything around it, I Yes.
Anand, any comments?
No, nothing more to add on that one.
Okay. All right. Excellent. All right. Well, again, thank you everyone for joining us today. Thank you for your questions. Be looking for an email tomorrow with a link to view the on-demand recording and any session and the session materials that were shared today. I do want to thank James and Anand for sharing their thoughts. Thank you, Thomas, for helping with the questions and the comments. As I mentioned before, if you would like to get started with model-based testing and generative AI, there is a link in the resources tab where you can request your free test modeler trial today. And you can also add AI-backed visual testing to your test by claiming your free Applitools Eyes account. Again, check the resources tab for that. And if you're ready to see more, both of our teams can provide a personalized demo for any of the solutions discussed today. Again, there are links on the resources tab for you as well. Finally, in the spirit of continuous improvement, we'd very much like to have your feedback on this event. There are 3 quick questions on the polls tab. Before you leave, please take just a minute to let us know your thoughts. Thank you for joining us, and we look forward to seeing you again.
Thank you, everyone.
Thanks, everyone. Bye-bye.